Okay, let's get started today. First of all, remember I videotaped these lectures. If you missed something, they are available toward the end of the day. I upload them to YouTube and I link to them via the lecture notes slide. So for example, last week's lecture is already up. So today we are going to be finishing up compiling and then getting into a review of input and output in C++, and we may or may not at the end of the day today get to printf, which is a new way of printing formatted output. If we don't get to it, we'll get to it on Thursday. So I put up this little diagram here because I think many of you may not yet have been introduced to the distinction between a compiler and a linker. Is that true? How many of you know what a linker is? Okay, only a few. So when you compile a program using G++, it is actually a two-step process. The first step is the compiler is invoked on the source file, which in this case, let's say I'm doing G++-O foo.cpp. So the first step, the compiler gets invoked, and it outputs a file called foo.o, which contains machine language. The .o file is a so-called intermediate file. It will be combined with some other files to form the ultimate executable, and the .o file will be cleaned up and removed. You won't see it. The linker is responsible for resolving what are called undefined functions or variables in your program. So for example, if you try to compile a program, so let's write foo. Okay, and I just do, let's see, int a equals 10, cout a end out. Okay, so no, I'm not including IO stream. I'm just trying to do this. So if I try to compile this, you see that it says error, use of undeclared identifier cout. That's actually, in some sense, a linker error because, well, actually this one isn't, but it's in some sense a linker error because cout and endl are not declared in foo or in foo.cpp. They're actually declared in the IOStream library. So in order to make it work, I actually add #include IOStream using namespace std. And if I compile it, it's now good. Whoops, it should have been good, except that but I do using Thank you. Now it works. So what has happened in the second case is that when I included IOStream, it was now, the compiler could now find that cout and cin were declared in a separate library, and it output foo.o. However, the less than, which is the output operator, is not, that function is not declared in foo.cpp. It's declared in the IOStream library. So in fact, in the link step, the linker is resolving that less than operator and finding it in the IOStream library. What it's doing is taking some code from the IOStream library and adding it to the foo.o. So foo is kind of a concatenation of foo.o and some code from the IOStream library. So foo is actually a combination of code from two different files. So there's actually two processes going on, the compilation step followed by what's called a linking step. Okay? Let's say that I create a function, int add, takes nothing, and I set a to be equal to add. Okay? So I've not provided a function body for add. I declared it, but there's no function definition for it, correct? Do we all agree? Okay. So there is another option you can give to the G++ compiler, and it's the -C option. It says compile, but do not try to link. Okay? Now, if I checked it out, I would see that there is a foo.o. Actually, let me remove foo and foo.h for the moment and just do that compilation. So there's a foo.o. It compiled correctly. Okay, the compiler was happy, but now let me try to actually do the full thing where I compile it into an executable. Now it fails. And notice the error message. It says LD, symbol not found for architecture, add. So it says undefined symbols for architecture, add reference from LD, symbol not found for architecture. Clang error. Linker command failed with exit code 1. See the bottom? Linker error command failed, or linker command failed. So when you see this LD, it means that a linker error occurred and you did not define one of your functions, which is what happened in that case. I never provided a function definition for add. Now sometimes you're including libraries like IOStream or Vector that contain those function definitions, and the linker finds them and all is well and good. And other times you don't, and you get that error message. So we're going to revisit this notion of a linker and a compiler later in the semester, because we will ultimately start compiling with multiple files. Okay, in industry where there's millions of lines of code, like Amazon's code base is millions of lines, clearly it's not practical to have the entire program in one file. And so programs are split across multiple files. And it turns out that add could easily have been defined in another file that would be linked together with this one. So in the real world, what you would often see is something like maybe foo.cpp and add.cpp. So the program might be split between multiple files. And what would happen here is that foo.cpp and add.cpp would first be individually compiled. So in this case, what would happen is foo.cpp would be compiled into a file called foo.o, and add.cpp would be compiled into a file called add.o, and then they would be linked together into the final executable called foo by essentially juxtaposing them together. But what's important right now is that you understand that there's actually two steps involved when you invoke G++. The first is a compilation step. The second is a link step where it resolves function definitions. It figures out for each function call where to find the function definition. So if you see a LD error, you know that that is a linker error and you have an undefined function, and you should look a little more carefully to see what it's saying, which in this case it's saying add was referenced, and now you should know that add is not, you never provided a function body for it. Okay, so questions about that? Okay, so moving on then, we've kind of finished the first day's work. We're moving into talking a bit about C-in and C-out today, about I/O. So most of it initially is going to be about C-in, but there's just a few kind of things that are in the notes but need a little bit more explanation. So first of all, you learned in CS102 that there are two ways to output a new line character. So if I want to have Brad and then I want a new line character, what is one way to do this? Pardon? Endl. Very good, Kim. And what is the second way? \n. Now, in his notes, Dr. Planck says that the two are equivalent. He's correct in that they both will produce a new line character. However, using \n is more efficient than using endl. I don't care which you use, but you should at least be aware that \n is more efficient than endl. The reason is that when you use endl, it immediately forces output to the screen. Okay, so when we use the C++ visualizer, for those of you who took it from me last semester, you had to use endl to immediately force output to the screen. \n buffers output, which means that instead of immediately outputting it, it puts it aside into a so-called buffer. So instead of immediately outputting, and it only prints the buffer when it reaches a certain size. Okay, you may do this too when you do online purchases. Amazon may say, we'll give you free shipping if you have $25 or more of purchases. So let's say you want to purchase a book and it's $10. You might decide to wait until you have a second item, say a power cord that costs $30, and when you combine the two, actually let's make it be worth $20. When you combine the two, they add to $30 and you get free shipping. But if you ship them individually, you'd pay shipping. It's the same idea here, is that by buffering the output, by continuing to add lines to this buffer and putting it out in one so-called mass burst, you save time. It's more efficient to output, say, a 256-byte string than, say, 25 10-byte strings. And so \n is buffering stuff up, and it's only outputting it when the buffer reaches a certain threshold. So it's more efficient than endl. I do not care which form you use in this class because it's not a huge deal. However, I do want you to understand that endl is a bit less efficient because it immediately flushes the line to the output rather than buffering it. Okay? Now, when your program ends, even if the buffer's not full, \n still pushes the output to the screen. So when your program finishes, whatever's in the buffer is forced out. So if you're just seeing a completed program, the effect is the same. But sometimes if you're seeing something in the middle of a program, it may not always be the same if you're using endl and \n because \n may be withholding some output from you. Now, it's also typically the case that if you do a cin, then \n will also force whatever it has in the buffer out. So it won't just wait until the buffer is full if certain conditions like cin is executed. So you can use \n with a prompt because when cin executes, the buffer is also flushed regardless of how big it is. Okay, next thing. You are going to see Dr. Plank using exit a great deal in his programs. He's an old school C programmer, and exit is the way that you prematurely exit it from a program. So in the past, it was a way that you exited from a program when there was an error. This is not the preferred way to exit from a C++ program. This is fine in C, but it turns out that in C++, we much prefer that you use return if you're going to exit from the program, even if it's an error and it's earlier. And the reason right now is a little arcane because we haven't really talked about something called a destructor. In 102, you learned how when an object was created, a constructor was called. Well, it turns out when an object is destroyed, a function called a destructor is called. And a destructor will sometimes release resources like, say, files or a hold on a network port. And the problem with exit is that it immediately gets out without executing any of these destructors. So if you have main and then you've called foo and then you've called goo and goo calls exit, exit immediately gets out without executing any of the destructors for objects that were created by goo, foo, or main. And if any of these destructors were releasing resources, those resources may not get released. So it is dangerous to call exit. C++ implements an exception handling mechanism whereby exceptions get thrown when something bad happens, and you're supposed to catch them in main. Now, you will not really encounter that until probably 365, a later course. And those of you in computer engineering may not actually encounter it. But the bottom line is, you will see Dr. Plank use exit a lot. I much prefer that you use return because it is the correct thing to do in C++. Now, if you need to return abnormally from a function other than main, it is fine to use exit for the time being because you have no better way of doing it. But should you be returning abnormally from main, please use return. Even though Dr. Plank's notes use exit. Okay, so exit is not clean. Return is. Okay, questions? Okay, another thing. The notes are introducing you to a concept called file redirection. So in 102, you learned about these two beasts called standard in and standard out. Standard in was where you read from the console. When you wrote to standard out, you wrote to the console. Okay, so what was used to read standard in 102? CN. What was used to write to standard out? Cout. So they would always write to the console. But that's not always what you want. Sometimes you would rather redirect the output to a file rather than the console. And sometimes you'd rather take your input from a file rather than taking it from a console. And to do that, in Unix, you can use the less than sign to do file indirection on the input, and the greater than sign to say that standard out should go to a file. So this says standard out should be redirected to a file. And this says that standard in should be redirected from a file. Okay, so let me, actually I've been on my feet for a while, so I'm going to take the duty to sit while I do this. So let's redo foo.cpp, and let's have it input A. So, and it will still output A equals. Okay, so very simple program, takes one input, produces one output. So if I compile this, all is well. If I enter 15, it says A equals 15. Now I'm going to try to redirect the output to a file. So I'll call it BVZ. So this is file redirecting standard out to a file called BVZ. So if I run it and enter 15, you see that there was no output to the console. But if I look at BVZ, I find it has the contents A equals 15. The command I used here, more, lists the contents of the file. So does cat. Dr. Planck often uses cat in his notes. The only difference is cat will show you the entire file at once. More will stop after a screen is dumped. So for example, let's see. Notice here, more stopped, and then if I hit the space bar, I get the next page where if I say cat, it just dumps the whole thing, which isn't as useful. So I like using more. At any rate, going back, we now see that the output got redirected to BVZ. I can also redirect the input. So I will have VI in, I'll set it to 20. And now if I run BVZ and take the input from in, that's foo, I get A equals 20 because I stored 20 in the file called in. And if I want, I can both redirect the input and the output. So this is going to says take my input from the file named in and redirect the output to a file named BVZ. Now if I look at BVZ, it's A equals 20. So questions about that? Okay, now there is a third thing that you may not have seen much of in 102, but there is a third stream called C-error, which is the stream you print to if there's an error. Say, oops, I did it again. Okay, so typically if let's compile it, and I'm taking input from in and redirecting to BVZ, and you see that, oops, I did it again, still printed out. That's because cout and cerr are two different streams. Cout goes to standard out, cerr goes to standard error, which is called the error stream. And sometimes you want the error stream to print on the console because you want the person to know that an error occurred. Okay, even while the regular output goes to BVZ. Now you can redirect the error to, so to greater than will redirect standard error on Linux. So now if I look at error, oops, I did it again. And finally, if I want them both to go to the same file, putting an ampersand there will combine the two streams. So now both standard out and standard error are both going to BVZ. Okay, so to greater than redirects standard error to a file. Greater than ampersand redirects both standard out and standard error to the same file. We good with that? Okay. Now, if I just run foo and I don't give it any input, it just sits there. It'll wait there until you shut down your computer or until you terminate the program. Okay. We have not actually told you how you terminate programs, but if you hit Control-C, it should kill it, at least on a Unix box and on the Mac. Okay, Windows boxes are a little more temperamental, but if you're running in Cygwin, Control-C should also kill it in Windows. Okay. So at any rate, no input, it stays there until I either restart my machine or I hit Control-C. However, let's say that I redirect from a file, and what I'm doing is I'm making my input file be empty. Right? We agree? Now I'm going to redirect it from in, and it actually ran instead of hanging. So what happens when you redirect from standard in is if there is no input, the cin goes ahead, attempts to make the read, and it fails. And what it prints out is whatever was previously in A. So let's say I had set A to be minus 10. You see A is still minus 10. It's because in this case, with the redirect, it attempted to read. Because there was no input, the read failed, and it left whatever was previously there in A, and so that's what got printed out. Okay? So, one of the things that you really need to do when you are working with CN is you need to often test to make sure that CN succeeded. Okay? In 102, what was one of the reasons that CN could fail? In fact, the only real reason CN could fail. There was a reason. Okay, so that would be a way it could fail, but we always said we would enter it correctly. So that's a good answer, but just not the way it could fail in 102, yes. Yes, very good. So at the end of the file, if I had a loop, let's say I had a loop, and it was while, remember this idiom? While CN into A, remember that? You were reading until you reached the end of the file. And when you reached the end of the file, so there was no more input, CN returned false to indicate that the read failed and you exited the while loop. So if I compile this, in fact, let's get rid of the, oops, I did it again. This will work as long as I'm entering input. Does anyone remember how you terminate console input? Control D. With Control D, that ends the console input, and in this case, the program ends. Just to prove that it didn't just prematurely exit. Okay, going to hit Control D, I'm done. So it exited the loop, and now it executed the cout. So you did see this idiom in 102, but there's other reasons why this could fail. Okay, let's say that I didn't enter an integer. Let's see what happens if I do not enter an integer. Let's enter Brad. Okay, it just came straight out of there with I'm done. Let's try something else other than Brad. Let's try Moose. Okay, it comes out of there with I'm done. Let's try, let's see, Zebra. Still out of there and I'm done. So what's happening in this case? Okay, did A ever print out? No. So it appears that CN failed, right? And the reason it failed is it couldn't figure out how to convert any of those words to a number. So it returned false to indicate that it failed. So that's another way CN can fail, is because it gets a bad value. Okay, so ways CN can fail. It gets an invalid. Okay. So, in CS102, we never confronted you with case 2. And if it's case 1, it's pretty clear that at that point you want to wrap things up and shut down the program. There are many cases, though, where you're going through input, you get an invalid value, and you want to continue processing. So you don't want to simply close things down. You want to keep going. Maybe you're going through a file and you're checking. Maybe we're human, right? We enter, maybe I'm reporting all your time cards. You've all given me time cards and I'm entering your information. Okay, I'm not perfect, I'm human. I may enter some errors when I'm entering your time cards. Maybe it's late and instead of hitting the 1, I hit an L. So maybe my program is going through the time card entries and it wants to report all entries that are invalid. Okay? So maybe my file is the number of hours worked. So, whoops, that's not right. Give me my cursor. Get rid of this puppy. Come on. There we go. Okay, so let's say my in file is 23 hours worked, 16 hours worked. Whoops, I did an L5. I meant to type 45, but instead I typed E5. I meant to type 75 or 76, but I typed YT. Finally got one right. So this is my input file. So I want to report any line which is an error. Okay? So how do I do that? Let's go back here and we'll call it now salary. No, hours. It was hours worked. I can't very well do cin into hours worked anymore because if there's an error, it will immediately exit. So I need some way to test cin to figure out whether or not there was an error. Okay? So the way I'm going to do that is I'm going to redo this. I'm going to now make it into an infinite loop. And I'm going to say if cin into hours worked, I will simply print however many hours we worked. Okay. And I would now like to say, if it failed, I will print something else out. But there's 2 reasons it could fail, right? What are the 2 reasons that cin could fail? End of file, and invalid input. So we need to distinguish those 2 cases. Okay? Well, there is a method called cin fail that you might think would work, but unfortunately it's true if either EOF or invalid. In fact, when you say if cin into hours worked, what it's doing is checking the fail function and it's returning the value of the fail function. So that's not going to help us. However, there is a second function which we told you not to use in 140, but which you're going to have to get familiar with in 102, but in 140 you need to get familiar with it. True if EOF. So what we're going to do is this gives us a way to distinguish between an invalid value and EOF. So we're going to say else if cin.eof. Does anyone remember how to get out of a loop? Break. So that's the way, even though it's an infinite loop, eventually we'll reach end of file and the break statement will get us out. Okay, else we know that it failed due to an invalid value. So we'll say else hours worked is invalid. And we will print the invalid value, except what's the problem? Well, it's not an int. It never got read. Right? Never got read. So let's just say ours is invalid and see how that goes. Okay, do we agree that this looks like a nice program? Seems to handle our three conditions. If it works, we print out hours worked. If we reach end of file, we break. And if there's an invalid piece of input, we discard it, print out hours worked is invalid, and we go back to the top of the loop. Okay, so when doing this, always start with just correct input. So I'll start with some correct input, 20, 30, 40, and 50, and run it. Not too successful. That's surprising. Does anyone know why it didn't work? Very good. If I just typed it, things would be dandy. I didn't give it a file with the indirect. Okay, very good. Worked perfectly. Now let's try it with my bad file and see how things go. Wow, looks like an infinite loop. You can tell because occasionally it is, you see there, occasionally it's catching up. So I just hit Control-C to kill it. So somehow I ended up in an infinite loop. Okay, so that seems rather strange because in had a fairly restricted set of stuff. Okay, so this is where you may need to get used to using a debugger. Okay, for the time being, because it's simple, I am going to, you'll learn more about the debugger in lab. Right now, I'm going to dump this into C++ debugger. So there's a, for those of you who did not have me last semester, if you go to orange.eecs.utk.edu, so the file name is orange.eecs.utk.edu/viz, you will come, second int /viz. It will prompt you for your user ID, and then you can enter a small C++ program. This has a 3,000 line instruction limit, so you can't run big programs in this, but you can run smaller programs. And I will enter standard in. It doesn't yet work with files, so you have to just use standard in. We'll copy this in like this, and we will put it in here. That's our standard in. We'll visualize the execution. This is going to take a little bit of time. Okay, it exceeded the instruction limit. Actually, there's only 2,000 instructions. So let's try and figure out what happened. The first one was 23, and we see that printed out properly down here. The next value is 16. That worked properly. The next value is 15. And whoops, let's see. Nope, the next value was L5, sorry. Looks like a 15, but it's actually L5. So let's go back, because this allows us to go back. So okay, so going forward, we read in L5. It says, did it work? No, it failed because it's L5. Did we reach end of file? No. So we're outputting hours worked as invalid. Okay, we go forward. And why didn't it print out hours worked as invalid? Because I use /n and it's buffering it. It's there, it's just buffering it. If I'd used less than endel, it would now be out there. So, in fact, it's going to go to the top of the loop. It's not actually executing I'm done. It's actually going up and it executed while true. And it's saying if cin hours works. So you kind of expect that it read E5 next, right? Kind of. So goes forward, prints hours worked as invalid. That seems to work. Now it should be reading YT. Now it should be reading 16, right? Whoops. That seems strange. It didn't work. Let's go back. This should be reading 16 right now. 16 looks like it's valid, doesn't it? Doesn't it look valid? Looks fine. It is. Our assumptions are wrong. Here is the assumption that we were making that is incorrect. We assumed that when cin failed on an invalid value, we could go ahead and read the next one. That was an invalid assumption. It's wrong. In fact, what happened, cin jammed. Just like a copier can jam on a paper feed, if cin tries to read invalid input, it jams, just like a copier jams. And just like once a copier has jammed, it can't produce any more copies until you clear the jam. Cin, once it's jammed, can't read another value till you clear the jam. Okay? So in fact, cin jams when you read an invalid value. Okay? How do you clear a copier? You remove the paper jam. How do you unjam cin? You call cin.clear. Okay? Unjams cin. and allows it to read again. Okay, so I'm going to go back, give you a moment to write this down, but I'm going to go back and I am going to add a statement that unjams CN. Okay. Got this down? This is also in the notes, but can't hurt to also write it down. So, not only am I going to print that it didn't work, but I'm going to do cn.clear to clear the jam. Okay, so I will recompile and I'll run it again. And, oh my gosh, it still doesn't work. Darn. So Dr. van der Zanden said that cleared the jam. What happened? Well, there's a second assumption we're making now, which is also wrong. Okay, so assumption 1 was wrong, but here's a second assumption. This part of it is also, which is we were making an assumption that when CN fails to read an invalid value, we assumed that when, this is important, we assumed that when CN fails to read an invalid value, it removed the offending value from the stream. It does not, nor does CN.clear. So in fact, while it's like, let's say that the copier has a button called clear, and you push it. Well, just because you push the clear button, you haven't done anything to physically remove the paper, right, that's jamming it. So just because you give the all clear signal to the Xerox copier, unless you've actually cleared the jammed paper, it's not really ready to go. It's the same thing with CN. If you haven't removed the offending value from the stream, it's still sitting there. So the problem, going back here, was that once we read L5 and it was invalid, it was not removed. Instead, it was still sitting there, and when we came back from here, even after we did cn.clear, and we came back up here, since L5 was still sitting there, it just got re-jammed. It tried to read it, it failed, it found it wasn't at EOF, it came out down here, it printed hours worked as invalid, it cleared the indicator, came back up here, reread L5, and it's stuck in an infinite loop because it's always going to read L5. So what do you think we can do about that? How do you think we can clear the so-called jam? We'd like to ignore it. Read it in as a string. So the way we do it is we read it in as a string. So I'll declare another thing called string invalid input. And after we clear it, we need to read it in as a string. That should always work. That should always work. You should always be able to read something as a string. Should never fail. And in fact, now we can kind of be a little more clear with our error message, because now we can say hours worked is invalid and print out the invalid input. And I'll do it with endl. So we clear the jam, we read the invalid value into this string variable, and that clears it. Does that make sense? It's a lot like clearing a copier, right? We pull the piece of paper out, and then we sometimes have to set a reset button. This is a great question, because yes, the order is incredibly important. Okay, I'll show you in a moment. This is the correct order. You actually have to hit the reset button first and then clear the jam. If you do it in the opposite order, which I'll show you in a moment, it won't work. Okay, so let's compile it and run it on foo, and there we go. It worked. So it properly identified the 3 invalid inputs, and it got through the entire file. And eventually, when it reached the end of the input, it exited. Okay? So that seems good. Now, the excellent question was, can we reverse the order? Because actually, if I'm going to follow faithfully with my analogy to a Xerox copier, I first need to clear the paper jam, and then I need to hit the reset button, right? It doesn't work the other way around. So it seems like this is actually the right way to go about it. Okay, so let's try it. Little hint, it's not going to go well. Back to the infinite loop. Okay, we can actually reason this through what went wrong. Okay, so let's reason it through. We tried to read L5, it failed. So we get to this else statement and we try to execute the CN. Can we actually, is the CN going to execute properly? No, because we haven't yet called clear. Remember, the first thing we have to do is call clear. If we don't call clear, it doesn't unjam the reader. So this statement actually fails because we haven't yet cleared the jam. Now we call clear, but it's too late. Okay? So what happens is we now come back up to here, and L5 is still on the stream, and we try to read it again, and we're back into our infinite loop. So the order, super important. So when clearing the jam, okay, so when clearing a CN jam, or to clear a CM jam, okay, call cn.clear, step 1. Step 2, read the invalid value into a string variable in order to remove it from the stream. And the order is incredibly important. It has to be exactly that order. It cannot be reversed. Okay, questions about that? Okay. So, let me just move on.
I have a question.
Yes.
I assume, are there other ways to go about it aside from reading it into a string to get rid of it? Are there other ways to flush it?
Not really. That's pretty much the only way I know how to do it. In this case, your assumption is not correct as far as I know. That seems to be pretty much the only way to clear it.
Okay.
I suppose you could no, there's really no other way to clear it. So that's it. You could do that. So you're right. You could read everything as a string and then check to see if it's a number, but that's being paranoid. No, that's an alternative way to do it, but generally we assume it works, and if it doesn't, we deal with it. Okay, so at the end of his notes, Dr. Planck has 4 common CN errors, which will probably bedevil many of you at one time or another. So the first problem, notice, by the way, when I was doing it, I always used the positive form. If it worked, I did something else, I did something else. But you can also do it in a bad way. So in this case, this program is reading 10 numbers. So you can see it's reading into N1. And if any of the numbers is not an integer, we want to prematurely end the program. So the idea is we're reading 10 numbers, but if there's not 10 numbers, let's say that the third number is L5, then we want to print done, and we want to return 0 and end. Okay, so the way he's doing it is he's saying if not CN into N1. Seems reasonable. If it didn't work, then we will exit. So he does it first with some good input, and then he does it with some bad input. And it turns out that when he does it with his bad input, let's see if we have his bad input. No, we don't. But we can create some bad input. Okay, first of all, does anyone remember what command will indent this properly? We're in VI. GG equals capital G. Whoops. Okay, now it's properly indented. Okay, so that's just the program. We will compile it and give it some bad input. And let's give it some good input. Oops, there we go. Wait. Yeah, it immediately failed. So actually, it just immediately failed. It didn't even let me enter input. It just immediately, pejoratively, printed out 10 zeros. Didn't even let me give it input. So how did it even know? Well, there's a reason. It has to do with the precedence of operators. There's 2 operators in here. One is the exclamation mark, and one is the greater than operator. And the person who wrote this code is making the assumption that C++ is interpreting it like this. They're assuming that the greater than operator has greater precedence than the not, and that it first will do the read, and then it will check to see if the read succeeded or failed. However, that's not the way C++ sees it. C++, hello, uh-oh, did we dump? Yes, we did. Oh, no, we didn't. What's... Yeah, not too good. Too bad. Okay, it looks like Smartboard crashed. Okay, so I'm going to have to do it like this. It actually thought it looked like this, if not seen into N1. So it actually gave higher precedence to the not operator. Okay, well, what does not seen do? Not seen, it actually goes and looks at the fail method. And currently, seen is not jammed. So the fact that it's not jammed means that seen returns true, to say, I'm good, I'm working. So if seen is not jammed, it returns true. So this converts the not seen into false. So what we get, if this were just working, is it working there? No, it's just totally busted. Ah, too bad. Okay, well, unfortunately, so what happens is this statement. I'd go and work on the whiteboard, except I'm videotaping this, so I can't. So this ends up getting into if false greater than N1. Guess what? Greater than is an overloaded operator. It doesn't always mean that you are reading. It also turns out, you'll learn out later in the semester, is a way to shift bits. So now it's trying to shift some bits. Okay? Pretty bad. But the whole meaning of your statement has been completely subverted. So false gets translated into an integer, 0. And now it's trying to right shift it by some number of bits, except that 0 will always be 0. So the bottom line is that this expression is false. So this expression right here is false, so it tries to print out number, but N1 was never set because the seen never occurred. Your whole solution is to just parenthesize the expression. And if you parenthesize it, it forces the read operator to be performed first and the not operator to be performed second. And we're all good. That last one was an L, not a 15. So the bottom line is, remember to parenthesize your, if you're going to say if not seen into something, you have to parenthesize it. Otherwise, the operators don't get evaluated in the order that you would expect. Okay. Here's the big one. The reason we told you not to use EOF and CES 102, and the reason it will still trip many of you in this course. EOF is not proactive. When you reach the end of the file, perversely, it will return false, telling you that you have not yet reached the end of the file. Okay? So here's a very simple program. It is reading strings one at a time, and it's going to end when the program reaches end of file. So we're saying while not end of file, increment I, read the string and print it out. Pretty straightforward, right? Seems like it should work. Let's give it a whirl. Okay, so let's get that puppy. and run it. So we'll give it Brad. That worked. Give it Nils, my brother. Give it my dog, Smiley. Okay, hit Control D. We're at the end. Whoa! String 4 is Smiley. I didn't enter a 4th string. Did I? Do you see? Here, let's do some input redirection. Maybe, let's see. Brad, Nils, Smiley. Run it. Whoops. Let's redirect. What gives? 2 times Smiley. Smiley's not in there twice. Right? Do we agree? Do we also agree it's printing out Smiley twice? Something's wrong. I mean, while not seeing. So let's see what's going on. Try to puzzle it out. So well, darn it. So we have Brad, and then we have, so the first time we come through, we have Brad. Actually, I am going to go to the board because it's just hard to read otherwise. So, if you're watching on videotape, I apologize, but the last 7 minutes are on the board. Okay, so our input is Brad, Nils, Smiley. Okay, so the first time through it says while not seeing.eof. We all agree that we're not at EOF, right? So we read Brad and we print it out. So Brad's gone. And this is where our read cursor is. So call this a read cursor. Just like you have cursors when you're editing files, right? So this is where our read cursor is. So it says, have we reached the end of the file? No, the last read succeeded, didn't it? Yes, it did. Okay, so we enter and we read Nils. Nils is gone. Our read cursor is right here. Our last read succeeded, right? So EOF is still false. Okay, so we read Smiley. Our read cursor is down here. We come up again, and what happened the last time we read? It succeeded, right? So EOF is still false. It's not proactive. So we enter the loop one more time. The 4th time we enter the loop, the cin statement fails because we actually reached EOF. So now it sets EOF to true, and the read failed, so S retains its original value, which was Smiley. So Smiley prints out a second time. Now we come to the top of the loop, and the read failed, right? And the reason it failed was end of file. So now it returns true, and we exit the loop one iteration too late. So that's what he means by seeing.eof is not proactive. It does not actually return true until you've attempted a read and it has failed because of EOF. So if you try this idiom, it won't work. It will apparently read the last line of the file twice. That's why in 102 we kept saying don't use this form of a read. Instead of writing it like that, read it like this, and your life will be incredibly happier. Because this will always work properly. It first attempts the read. If the read fails due to EOF, it returns false, and we're out of there. So it combines the two. But the reactive form is okay in this case because they had attempted the read first. When the read fails, it returns false and we're gone. Okay? So that's the big two. I actually don't find error 3 to be such a big problem. Just know that cin reads a word, not an entire line. So if I enter input that looks like this and I call cin, the first time I call cin it reads 10. The next time I call cin, does it read 110 or does it read 11? Let's do a show of hands. How many think that the next value read is 110? And how many think it is 11? Okay, it's 110. So that's what this is meaning. It reads a word and not a line. So when it's done reading 10, the next thing available is 110, and so that's what it will read next. Does that make sense? Truly make sense? Okay. So it doesn't read a line, it only reads one word at a time. And this was the error that I just spent a lot of time talking about, which is that when cin jams, you can't just call the clear command, you also have to read the invalid value into a string variable. If you fail to do it, you've actually failed to clear the jam, and you'll end up in an infinite loop. Okay? So that takes care of cin. We will pick up on Thursday with printf. Also on Thursday, we will pick up with the assigned topic for Thursday.